Good day, everyone. My name is Adeosun Titilayo. I'm from the Department of Microbiology, Adeleke University, Osun State, Nigeria. First, I would like to thank the Beyond Science Initiative for availing me the opportunity to present at this conference. The topic I'll be presenting is the resistance pattern of Staphylococcus aureus isolated from State Specialist Hospital, Osogbo, Osun State, Nigeria. Introduction. Staphylococcus aureus is one of the most highly resistant bacterial pathogens that have been increasingly reported around the world. This organism is capable of acquiring resistance to various antibiotics and is a leading cause of hospital and community-acquired infections that can manifest from minor skin diseases such as boils to life-threatening infections such as pneumonia, cardiovascular infections, among others. Bacteremia, that is the presence of bacteria in the blood, can be caused by Staphylococcus aureus also, which is a common cause of morbidity and mortality, that is, increase in death rates in humans worldwide. Justification. Information on the isolation and the antibiotic susceptibilities of the hemolytic strains isolated from the bed sheets, the doorknob, the floor, the hospital furniture such as the table and the chair, in which patients and healthcare workers contact regularly, is often depleted. This research work therefore focuses on the isolation and the antibiotic sensitivity patterns of Staphylococcus aureus isolated from the Osun State Specialist Hospital, Ajibade Rural Environment, Osogbo, Osun State, Nigeria. The aims of this study include 1. To isolate and identify Staphylococcus aureus from the different spots within the different wards of Osun State Specialist Hospital, Environment, Osogbo, Osun State, Nigeria. 2. To determine the types of the hemolytic strains of Staphylococcus aureus from the different spots within different wards of Osun State Specialist Hospital, Ajibade, Osogbo, Osun State, Nigeria. And to determine the antibiotic susceptibilities of the hemolytic strains of Staphylococcus aureus from the different spots within the different wards in Osun State Specialist Hospital, Ajibade, Osogbo, using the standard antibiotics, that is the oxoid products. The materials and methods employed in this study. 1. From the sample collection, there were some units where the samples were obtained from the hospital environment, and these units include the intensive care unit, ICU, the male ward, the female ward, the emergency unit, the dressing room, and the labor ward. Surface swabs were aseptically taken with labeled sterile swab sticks from different spots. These spots are the target spots, and they include the bed bar, the doorknob, the bed sheet, the table, chair, and the floor at each of these units. And in total, 36 swab samples were obtained and transported at 4 degrees Celsius using ice packs to the microbiology laboratory, Adeleke University, Ede, Osun State, Nigeria, and they were processed immediately. After the transportation to the laboratory, the detection and enumeration procedure of S aureus was carried out according to the method described by Sami and Chimbabu 2011. In this method, it employed the utilization of a selective medium for Staphylococcus aureus, which is known as the mannitol salt agar. After which, the biochemical characterization and identification of the Staphylococcus species were carried out according to Chesebro 2002. And these biochemical methods employed include the gram staining, the catalase test, the coagulase test, among others. Then the determination of the hemolytic strains of Staphylococcus aureus was performed according to the method previously described by Jimenez et al. 2008. The antibiotic susceptibility of the hemolytic strains of Staphylococcus aureus was carried out according to the methods standardized by the Clinical and Laboratory Standard Institute, CLSI 2011. The distribution of Staphylococcus aureus per location in the hospital was calculated and the percentage distribution was obtained. After which the statistical analysis was done using the SAS package, and the statistical significance was defined by a probability value less than 0.05. The results on the isolation of the Staphylococcus aureus using the selective media, the mannitol salt agar, the swab samples obtained from the hospital environment showed golden yellowish colonies on mannitol salt agar, that is, they had the ability to ferment mannitol. All the 36 swab samples had Staphylococcus aureus colonies. Out of a total of 382 isolates of Staphylococcus aureus, 269 isolates tested positive to all of the confirmatory tests used in this study. Here's the table 1 showing the distribution of Staphylococcus aureus within the hospital environment. On the vertical axis, we have the locations within the hospital, where we have the intensive care unit, the emergency unit, the labor ward, the female ward, the male ward, and the dressing room. And on the horizontal axis, here we have the number of the Staphylococcus aureus from the spots of sample collections within each of the locations. In the ICU, the bed bar revealed the highest number of Staphylococcus aureus with 10 isolates. In the emergency unit, the bed sheet revealed the highest number of Staphylococcus aureus with 7 isolates. In the labor ward, the floor revealed the highest number of Staphylococcus aureus with 10 isolates. In the female ward, the bed sheet revealed the highest number of Staphylococcus aureus with 13 isolates. And in the male ward, the bed sheet also revealed the highest number of Staphylococcus aureus with 20 isolates. Then in the dressing room, the door revealed the highest number of Staphylococcus aureus. The distribution of the hemolytic isolate of Staphylococcus aureus obtained from Osun State Specialist Hospital environment as follows. Out of a total of 269 Staphylococcus aureus isolates, 17.47% showed hemolysis on the blood agar. Then the differences in the incidence of the hemolytic isolates were significantly different, with the probability value less than or equal to 0.05. The highest hemolytic Staphylococcus aureus isolates was found in the emergency unit with 4.83%, followed by the female ward with 3.71%, followed by the ICU with 3.34%, followed by the male ward with 2.97%, and the least in the labor ward with 2.60% respectively. However, hemolytic strain was not identified in the dressing room. The percentage of the hemolytic Staphylococcus aureus within the sampling spot in the hospital are as follows. From the doorknob, 4.10%, the bed bar, 3.72%, the bed sheet on the table, 3.34% each, the chair, 1.85%, and the least was from the floor, 1.11%. Here is table 2 showing the distribution of the hemolytic Staphylococcus aureus within Ajibade hospital environment. On the vertical axis again, we have the locations within the hospital, and on the horizontal axis, we have the number of the hemolytic Staphylococcus aureus from the spots of sample collection in the locations. In the ICU, the bed bar revealed the highest number of the hemolytic Staphylococcus aureus with 4 isolates. In the emergency unit, the table revealed the highest number of the hemolytic Staphylococcus aureus with 5 isolates. In the labor ward, the doorknob revealed the highest number of the hemolytic Staphylococcus aureus with 3 isolates. In the female ward, the bed bar revealed the highest number of the hemolytic Staphylococcus aureus with 4 isolates. In the male ward, The doorknob revealed the highest number of the hemolytic Staphylococcus aureus with 4 isolates also, and there was no record of hemolytic Staphylococcus aureus in the dressing room. Here is the third table showing the distribution of the beta hemolytic Staphylococcus aureus within Ajibade hospital environment. In the intensive care unit, the bed bar showed 4 isolates of beta hemolytic Staphylococcus aureus. The emergency unit, the table showed the highest number of beta hemolytic Staphylococcus aureus with 5 isolates. In the labor ward, the doorknob revealed the highest number of beta hemolytic Staphylococcus aureus with 3 isolates. In the female ward, the bed bar revealed the highest number of hemolytic Staphylococcus aureus with 4 isolates. In the male ward, both the bed sheet and the chair revealed the highest number of beta hemolytic Staphylococcus aureus with 2 isolates. And in the dressing room, there was no record of beta hemolytic Staphylococcus aureus. Here is the fourth table showing the distribution of the alpha hemolytic Staphylococcus aureus within the Ajibade hospital environment. In the intensive care unit, the bed sheet revealed the highest number of the alpha hemolytic Staphylococcus aureus. In the emergency unit, the bed bar revealed the highest number of the hemolytic Staphylococcus aureus. In the labor ward, there was no record of alpha hemolytic Staphylococcus aureus. In the female ward, the table revealed the highest number of the alpha hemolytic Staphylococcus aureus. In the male ward, the table also revealed the highest number of the alpha hemolytic Staphylococcus aureus. In the dressing room, there was no record of alpha hemolytic Staphylococcus aureus. Here is the result of the antimicrobial sensitivity of the hemolytic Staphylococcus aureus. The antibiotic sensitivity test showed that all Staphylococcus aureus were resistant to ampicillin. It was an 100% resistance, followed by tetracycline with 59.37%, followed by chloramphenicol 43.75%, followed by ciprofloxacin 15.63%, and the least resistant was to gentamicin 15.5%. Here is the table 5 showing the antimicrobial sensitivity results of Staphylococcus aureus isolates from Ajibade hospital environment. On the vertical axis, we have the antibiotics with their corresponding disc content, and on the horizontal axis is showing the number of isolates that are susceptible, number of isolates with intermediate susceptibility, and the number of isolates that were resistant. The first antibiotic tested was ampicillin with 10 microgram. There was no susceptible isolates, no intermediate isolate, but we had 32 resistant isolates. For chloramphenicol, 14 isolates were susceptible, 4 were intermediate, and 14 were resistant. For tetracycline, 7 isolates were susceptible, 6 were intermediate, and 19 were resistant. For ciprofloxacin, 21 were susceptible, 6 had intermediate susceptibility, and 5 showed resistance. For gentamicin, 27 isolates were susceptible, 1 showed intermediate susceptibility, and 4 isolates showed resistance. The discussion. Staphylococcus aureus have been reported as one of the most common nosocomial pathogens, usually isolated in the hospital environment, as recorded by Chikere et al. 2008, Ahmad 2010, Qatar et al. 2015, and Kitara et al. 2011 reported higher prevalence of Staphylococcus aureus in the female ward, which corroborates the results obtained from the study. Furthermore, the results from the study revealed that women are more prone to infections from microorganisms, especially the infections caused by the Staphylococcus aureus, that is the organism in question. And this can be due to poor hygiene of the individual patients, also lack of proper cleanliness of the hospital environment. Bloomfield et al. 2011 described high occurrence of the Staphylococcus aureus from the clothing and bed linings. There is highest isolation of S aureus from the bed sheets have been reported which also corroborates the results obtained from the study that reviewed the highest number of Staphylococcus aureus from the bedsheet among other sampling spots. Gibson et al. 1999 reported that it is possible that transmission of contamination onto clothing bed linings or the bed sheets can occur from contaminated sources via hands, contact, skin, among other means. The least percentage of S aureus, 11.90%, was isolated from the tables in the hospital environment, and this did well to corroborate with the study carried out by Idowu et al. 2003, who opined that tables are mostly cleaned, and constant cleaning of these tables is able to kill off the pathogens it might be carrying. The results shows that Staphylococcus aureus isolates showed 100% resistance to ampicillin, which is in line with the study carried out by Gabriel and Kebe in 2017. In this study, a high sensitivity percentage to gentamicin, 84.38%, was recorded. It showed that staphylococcal infections could be treated with gentamicin, which also corroborates with the research carried out by Uba and Uma 2002. In conclusion, it is evident that Staphylococcus aureus is present in the hospital environment studied. Also, gentamicin can highly inhibit the growth of hemolytic strains of Staphylococcus aureus. The recommendations are: 1. There should be surveillance and continuous monitoring of the antimicrobial susceptibility patterns of Staphylococcus aureus, as it is of utmost importance in understanding new and emerging resistant trends in the management of infections associated with the hospital environment. Also, the high isolation of Staphylococcus aureus in the female environment could be resulting from poor hygiene of individual patients and lack of proper cleanliness of the hospital environment. Hence, it is imperative that there should be proper cleanliness of the hospital environment, especially the female ward, and females should work more on their personal hygiene. Here are the selected references used in the course of this research work. On this note, I want to say a very big thank you for listening.